What page?
159, 6.
Yay. All right, so evens? Yay?
Yes.
All right, so let's just take a look at them and see how we do. Please feel free to write down any notes that you need to. So it says, determine whether the equation represents exponential or not. It looks exponential to me, but what happens when I just keep plugging numbers in? What's my result going to be every time? Well, let's do this. Let's plug 0 in. 1 to the 0 is 1. 1 times 5 is 5. Let's plug 1 in. 1 to the first is 1. 1 to the second is
1.
1 to the third is 1 to the fourth. 1 to the 155,000 is 1. So we're just going to keep getting 5 out the whole time. So no matter what I plug in, I get 5 as an answer. So is it going to be an exponential function? What happens with the exponential functions? Do they tend to grow or not grow? So I don't think it's an exponential.
I thought exponential was when x is just on its own.
So exponential is when x is the exponent, but this base needs to be something else. Because in this case, no matter what I plug in, I'm going to get 5 out. No matter if it's negative, positive, 0, I just keep getting 5 out.
So if it was going to be linear, what would the base be?
Linear would have the x down.
So the x would be like, okay.
So this would be like linear if it was like this. Something like that. But this one isn't even, this is not exponential just because that base, this 1 goofed up the whole thing. Okay? Does that make sense? So we're just doing evens, right?
Yeah.
Okay. In exercises 4 and 5, determine if the table represents linear or exponential. Now let's take a look. 1, 5, 2, 2, 3, -1, 4, -4, x, y. Cool. All right. So I feel good about this. 1, 2, 3, 4. That's sequenced, right? I mean, we should see that. And then let's see. If I go from here to here, I'm going to subtract 3. Do you agree? And then if I go from here to here, I'm also subtracting 3. If I go from here to here, I'm also subtracting 3. So I have the same thing happening over and over and over again. So linear is going to take place with this. If it was exponential, those would not be the same. They would be like growing really big or getting really small. All right, 6. Evaluate the function for the given value of x. Okay, 6. F of x. Oops, no, it's not even that. Y is equal to 1.2 raised to the x. And they want us to plug 2 in. Alright, so I'm going to pull up my calculator if that's okay. Alright, so I'm going to replace the x with a 2. Agreed? So right now this is going to become 1.2 raised to the second power. Okay? Alright, so let's get off this stuff. So 1.2 raised to the second. Ready? No, I don't want this. I'm going to clear all this out. I guess I can clear that out. I don't need that. Trash that. Alright, so what was it? It was what?
Y equals times 1.2x.
1.2, and then it's raised to the x. And what number am I plugging in for x?
2.
2. So that's an exponent. That means it's going 1.2 times 1.2. So it should come out to 1.44. Yep. Cool. So 1.44.
Are we allowed to use like the calculator on that?
Yeah. Yep. Number 8. We want to graph it and compare the graph to the parent function and then describe the domain and range. Okay, so let's go insert. That's math. Graph. Okay, so what is a really good way to approach this problem? It's exponential, agreed, because the x is the exponent. So I would think let's make 0 comma something a point. So 3 raised to the 0 power 1. Okay. 0 comma 1. All right. So let me ask you all this. Is there technically a 1 right there?
Yeah.
So let's think about this. Y equals AB to the x. So take a look at this. Let's keep that in mind. And then I'm going to go to the right. And go to the right one. What am I going to multiply my y value by in this case?
3.
3. So 1 times 3 is 3. And then I'd go 3 times, go right one more, and go 3 times 3, which is 9. So 6 and 8. So it's like way up there, right? So this graph is doing this. Now there's one thing I want to bring into here. I'm going to draw a pink dotted line right there. Okay, that's a term called an asymptote. An asymptote is something that your graph under normal situations should not cross. So what's happening is this red line is getting closer and closer and closer to this pink line. It'll never go below it and it'll never touch it. Okay? So it says compare the graph to the parent function graph. Well, that's basically the parent function of 3 to the x. It's not really doing much. And then the domain. So is this graph going forever that way? Yeah. Is it going forever this way, even though it's growing? So like if I came way out here, if I looked way up there, would that graph be up there? So it's continuing to grow. So it's going from negative infinity to positive infinity. In fact, for all of the ones that we're dealing with, that the domain will always be constant. The range is where things change. Okay? So if I'm way down low, riding an elevator down low, if I look out either side, I can only see horizontally. I can't see up and down. Can I see the graph way down here? No.
No.
But as I come up to that pink line, just as I get on the other side of that pink line, I can start seeing it. That pink line in this case is 0 and going to infinity. $10. H at x. Hey, is h at x the same thing as y?
Yes.
Yeah, it's just a fancy way of writing it. So if we just look at it, do we know it's exponential? If so, why is it exponential? What's my exponent? X. So is it exponential? What if my exponent was 7? Then it's not. And that's the big right there. All right. So a few things. Let's do what we know how to do. We know how to plug 0 in. 1/2 raised to the 0 power. 1. Okay. All right. All right. So I'm going to go right 1. What do I multiply 1 by in this case? Half. So what's half times 1? Half. What's going to go right 1 more? What's half times half.
1/4.
Then 1/8, and then 1/16. So this is like totally coming down this way. This is what this graph looks like. And again, I'm going to draw this pink line in. What did I call this pink line on the last problem?
The hour.
Asymptote. Good. Okay, an asymptote, in most circumstances, it should not cross the asymptote. All right, so domain, negative to positive infinity, because I can plug anything in for x and get something out. My range, elevator down here, coming up. When do I start seeing?
There.
At the pink line, right?
Yeah.
Right? Just as I cross the pink line. So it's going to be a rounded bracket at 0, going to infinity. We A-okay? You think 12's what? Well, let's take a look. Can I go to 12? Now 12 I didn't really cover yesterday, but that's why I'm going to go over it. Let's make sure we're good. Actually, can I do this? Can I do 11 and 12?
Yeah.
Okay. So graph, cohesion. So I know I didn't assign you number 11, but just go ahead and write this in. That's supposed to be f at x. I don't know where the other parentheses went running off to. So just take a look at this one. Does it appear to be slightly different than what we've been working with?
Yeah.
What appears to be a little bit different? The 3. Okay? So I'm adding something to it. Okay, so remember we talked about the asymptote before? Where was the asymptote before on the last two problems?
0.
0. Is that y equals 0? Right? So this, because I'm adding 3, this is going to change my asymptote. T-O-T-E. Okay? So my asymptote here is going to be here. See how that just moved up? That makes sense? Okay? And all the other rules are still going to apply. So if I plug 0 in, so 1 over 2, 1/2 raised to the 0 is how much? 1. Okay, so that gives me 1. So if I did this, that would mean that the next step is this. Is that okay so far? Then I get -6, and just multiply that plus 3, and that just gives me -3. -0, -3, that's like down here, isn't it? Ooh. Okay. So here's the tough thing on this problem. That pattern graph might work, but I think there might be a lot of things to think about. So what would happen if I plugged another number in? And what would be a good number? I've plugged 0 in so far. What would another good number be, maybe? Something within this grid, would you think?
Yeah.
So pick a number between -6 and +6. 1. Go with 1. Good call. Let's plug 1 in and see what happens. Okay. So I get -6 times 1/2 to the first plus 3. What's 1/2 to the first? 1/2. What's -6 times 1/2? -3, and I'm going to add 3. So 0, 1. Ooh. What would be another okay number maybe to plug in? Yeah, I'm just trying to decipher what this graph's going to look like. So I'm going to plug 2 in. So I get -6 times 1/2 raised to the second plus 3. So what's 1/2 times 1/2? What's 1/2 times 1/2? 1/4. Okay. So then I get -6 times, so that's -6 over 4 plus 3. That's -3 over 2 if I reduce that, plus 3. So that's going to give me positive 3 over 2. You're like, wait, how did you get that? Well, that's going to be the same thing as 6 over 2. Negative 3 plus 6 is 3, so 3 over 2. So 3 over 2 is like 1.5. Is that okay? So 2 comma 1.5. Can you see what this graph's doing? It's doing that. All right, domain. Negative to positive infinity all day long. Range. Ooh, I'm coming up from here. Do I see the graph as I'm coming up? Do I see the graph down here? Yeah, so negative infinity. And when do I stop seeing the graph? Right there. Good, so that's at 3. Ooh, so our range changed a little bit. So if I add something to the outside, that moves the asymptote up. It moves the asymptote, it changes our range. Domain stays the same. And then let's look at number 12 as well. Is that cool? Is there any questions on that one? So is it okay how I plug values in? And don't, pick the simple values. Don't pick things that are these huge numbers. What number did you plug in for x? 455,000. Okay, why? Seemed good. Our graph goes from negative 6 to positive 6 on here. Or I guess on yours is negative 10 to positive 10. All right. Math, graph. 12, is that okay? Number 12. So g at x, that's a fancy way of writing y. 2 raised to the x minus 4. So is it an exponential graph? If so, how do we know?
No.
What's my exponent? Is it exponential? Yeah. Thoughts? Do you think the asymptote's going to move on this one?
Yes.
You think it's negative 4? I think you're absolutely right. Negative 4. That negative 4 means my asymptote shifted down. So again, my range is going to be affected. All right. I don't know if it's come from the bottom or not. Let's do plug 0 in. 2 to the 0. 1. 1 minus 4. Negative 3. That doesn't really tell me the direction it's going, but maybe we can get there. Can I plug 1 in maybe? What's 2 to the first? 2. 2 minus 4? I can plug 2 in maybe. Maybe that'll give us a little more information. 2 to the second power? 4. 4 minus 4?
0.
Oh. I definitely see what this graph's doing. Domain? Negative to positive infinity all day. Range? Negative 4 to positive infinity. Good. Good. Good.
Will domain always be negative infinity to infinity? Or most likely for this?
The domain on these, negative positive infinity all day long. So if you see, I'd say on the next time you take a quiz or on the final, if it's asked for the domain, negative positive infinity all day long.
Okay.
Don't go and try and change it. When you get to Algebra 2, we're going to goof it up for you, and I apologize. But you saw a pretty cool Algebra 2 class yesterday, huh?
Yeah, it was pretty interesting.
I allowed them to take their very last test on conic sections, which is parabolas, circles, ellipses, and hyperbolas. And so do you remember when we started doing parabolas and I said right now it opens up and down? When I taught them over the past 2 weeks, they had parabolas open right and left. So, but I allowed them to take their very last test in groups. And then I gave them the last 6 minutes. I said, if you can't figure out a problem, go find a group that's got it. Worked out well. I thought it was cool. I didn't make it count as much as a normal test grade. I think I made it 10 points versus 70. So the kid's like, dude, can I get an A now? No. All right. 13 and 14. 13 and 14. We already did 13 yesterday. So look at 14. The only difference about number 14 is the asymptote moved down. So on number 14, the g at x equation is 0.5x, and that looks like the asymptote moved down to -2, so -2. That's good. Did you all do the homework?
Yeah.
If not, did you fill it in while we were doing it? You say you did. So go ahead and put a big old 4 at the top, and I will make sure if you are here that I will put that point value in. Actually, do me this favor, Aiden. Remind me before the end of the class that I put points in for today's assignment. Cool? If you forget, Emily, you're second in command.
Got it.
Okay, Joy, you're third in command. So don't give me, is that 2 nights ago?
That's yesterday.
Yay! And I apologize in advance. These are the longest notes you're going to see for the entire year. You believe that? Aaron, will you put one on for us too? And if anyone has any old homework, not today's, but any old homework, just bring it up, put it on the desk. And grade 5. Let's see. Let me do this pretty quickly. Old homework's coming back to you. So I'm sorry in advance how long the notes are for today. Okay. Let's walk through these. You ready? We set? We going? Oh, is it, what is that?
I think this is the homework.
Old homework. Oh, wait.
Wait.
Just someone hand this in. Was this last night's?
Yeah.
Oliver.
That was last night.
Oliver. What page is this? Oh, Oliver. This was.
That's all of our homework. Yeah, I just turned
Oh, no. Don't turn in today's homework. I'll put the points back in for you.
Wait, no, this is yesterday's. He said, wait, no, cite, never mind.
I have yesterday's. Yesterday's it got covered.
And then here's all this.
That
Okay.
I gave Aiden yesterday.
All right. There you go.
One of them is Aaron knows.
Yep.
And then those yesterday's.
That's yesterday's. Yeah. Is that yesterday's? Wait, is that yesterday's?
Yeah.
Oh, okay. That is before. I'll put that in the book for you. All right. So yeah, don't turn in 159 and 160 today. All right, let's walk through this.
Wait, if he is on top of that.
What, so sketch the graph. Okay. So, what do you feel my asymptote would be up here? How much?
0.
0. Why 0? Because there's nothing over here. So there's a plus 0 over here. So that says my asymptote's right here. Is that okay so far? Okay. And let's try and sketch the graph. Let's maybe plug 0 in. If I plug 0 in, 1/2 raised to the 0 power is 1. 1 times -8. So 0, -8. Okay. And I think I could pattern off of this one maybe. Or maybe it's just easier to plug 1 in. If I plug 1 in, 1/2 to the first is 1/2. -8 times -1/2, or -8 times half, -4. 1 -4. And maybe just plug 2 in, just to see what happens. If I plug 2 in, 1/2 raised to the second is 1/2 times 1/2, which is 1/4. 1/4 times -8 is -2.
Yeah.
There it is. Okay. What does it appear the y-intercept is up there? Where's it cross that vertical y-axis? Yeah. So the y-intercept, and let's list it as a point. So 0, -8. Is that okay? What is the equation of the horizontal asymptote? Well, the equation is y equals 0, because y equals 0 is a horizontal line, and at 0 goes right over the x-axis. Oh, rate of change. Huh. From -1 to 0, what is the rate of change? All right, so I want to plug one more point in. I want to plug -1 in and see what happens. If I go 1/2 to the -1, 1/2 to the -1, the 1/2 flips over and gives me 2 to the first, or 2 over 1. So that's going to give me -16. So I get -1 comma -16, and I wanted the 0 value as well. So 0 comma -8. What in the heck does rate of change mean? The slope is exactly right. Okay, so rate of change means slope. So that means slope. So we have to go back and kind of remember our slope equation. Our slope equation is y2 minus y1 over x2 minus x1. So if I come over and label it x1, y1, x2, y2. So let's plug those in and see what happens. I'm going to get -8 minus -16. And then I'm going to get 0 minus -1. That negative becomes plus. So what's -8 plus 16? 8. And then 8 over 1. So my rate of change on this one is 8. Okay. Now it's asking for the rate of change from 0 to 1. 0 to 1. Well, I know I have 0 comma -8. And what happens at 1? What happens at 1? What happens at 1? 1 -4. Okay. So again, I'm going to do the exact same thing. x1, y1, x2, y2. Okay. So I'm going to go -4 minus -8 over 1 minus 0. Minus means what? Positive. So -4 plus 8 is 4. 4 over 1 is just 4. I have a rate of change on this one of 4. Okay. Let's say here it says, what is the rate of change from x equals 1? Well, that's 1 comma -4. And then what's the other one? 2 -2? All right, so let's again find the slope of this one. So that's x1, y1, x2, y2. Find the slope using our slope equation. So I have -2 minus -4 and 2 minus 1. What's the negative do? Positive. So -2 plus 4 is 2. 2. 2 over 1 is 2. Does the slope change? So the rate of change is happening. So what they're basically doing is saying, hey, here's a slope at a certain point, here's a slope, here's a slope. Notice how the ruler is changing? Or what I could do is this. So I have a slope here. That's a certain slope. And I have a certain slope here. And then I have a certain slope here. You see how that line's changing direction a little bit?
I hate to tell y'all this, but I just suckered y'all into doing calculus just now.
Oh, that's it?
That's calculus, part of calculus.
Oh.
That is a calculus problem right there. Okay, but what they want you to realize is there's a rate of change. There's a rate of change and it changes. Does the rate of change on a linear equation? No, the slope stays constant. the rate of change here is changing. Okay, what did you notice about the rate of change? It looks like it's half each time, I think. So the slope changed. There's your calculus. Man, that's calculus right there. Woo! Go home saying, dude, guess what I just did? I signed up to take the AP Calc test. Monday next week. Parents are you sure you're ready? Mr. Stirp taught us. All right. So let's try this one. They want us to graph it. So what does my horizontal asymptote appear to be? -4. Absolutely. Is that okay so far? And I think we're going to try and sketch this. Uh-oh, -1. I think that goes to 0. 0 to 1. All right. So what I'm actually going to do is I'm going to plug in this value, and this value, and this value. So -1, 0, 1, and 2. Okay? And that way we get some points out of it. All right, so let's just do this even as a t-table. So I'm going to plug in -1, 0, 1, and 2. Is that okay so far? All right, let's walk through it. 2 raised to the -1. It flips over, doesn't it? A negative exponent flips it over. So how do I flip 2 over? 1 over 2, so half. Half times 2, 1. 1 minus 4, -3. Okay. So -1, -3. Okay. Let's plug 0 in. 2 to the 0.
1.
1. 1 times 2. 2. 2 minus 4.
4.
-2.
Yeah.
0, -2. Okay. All right. Let's plug 1 in. 2 to the first. 2. 2 times 2. 4. 4 minus 4.
0.
0. Okay. That's right there. Plug 2 in. 2 squared.
4.
4. 4 times 2. 8. 8 minus 4.
4.
2 times 4. So that is taking place. So let's see. What is y-intercept? The y-intercept is 0, -2. What is the horizontal asymptote? Y equals -4. What is the rate of change? So again, if I'm going to do rate of change, that means I have to do my slope equation. All right, so let's do this one. We want this one first. Okay, so let's see if you can follow along. -2 minus -3 is -2 plus 3, which is 1 over 0 minus -1, so 1 over 1. So the rate of change here is 1. So that means the slope of this line, right here, is a slope of 1. Okay? What is the rate of change for this next one? So I'm going to I'll do this one in green, looks good. I'm going to do these two. Okay? Let's see if you can follow my work. 0 minus -2 is 2. Okay? And then 1 minus 0 is 1. So I get 2 here. So from 0 to 1, I have a steeper slope right there. And then from 1 to 2, it's purple. 4 minus 0 is 4. 2 minus 1 is 1. This would be a 4. Here to here, slope of 4. Is the slope changing? Yes. Is the rate of change changing? Yes, rate of change, and it's increasing on this one. Wow. Second calculus lesson in the day. You had no idea you were walking into it. All right.
What
Pay-
did you do for G?
Do what? What was G? What did it say? What do you notice about the rate of change? It's changing. So you have a slope of 1, slope of 2, slope of 4. It's not staying the same. It's changing. So I would think page 161, page 162. And it's just 2 problems. But that would be 100% appropriate for you all to dance with today.
Did you collect homework?
No, but someone's supposed to remind me of something. Woo, you guys are on camera, yay!